Welcome, everyone. Thanks for joining OWASP AppSec Days India Virtual Edition. I am your host, Karan Shah, and here we are with our next session, which is going to be given by Naveen S. His topic is building Git hooks for your organization. A little introduction about Naveen. Naveen works with Freshworks as a lead security engineer. Naveen has worked in streamlining and automating security workflows in the application security and SOC functions. His vision is to build DevSecOps culture that encourages everyone to learn and grow. So, welcoming Naveen on stage. Hey, Naveen.
Hi Karan, how are you doing?
Yep, I'm good. How are you?
Doing good, amazing. Excited to
Awesome,
be here.
awesome. The stage is all yours, Naveen.
Okay, great. Thanks. Uh, hey everyone. Super happy to be here presenting with AppSec Days India. And this being the very first edition in India, I'm super excited to be a part of it as well. Uh, so today, we're just going to look at something which we don't usually talk about. And given with the trend that's going on all about AI and all of that automation things, we're just going to talk about something a little bit conventional today, something which has been there for a long time, and uh, we'll just talk about how we can leverage certain things about our day-to-day tools to make security posture better in an organization. So we'll be talking about Git hooks and how you can build and scale the Git hooks for your company and take success from that. So we'll walk through it. So Karan gave me a little bit, gave an introduction about me, but just to walk through. So I am a cybersecurity professional. I am into the supply chain and software field. I am also into DevSecOps. I work at Freshworks. I'm into the security engineering team, taking care of the software development lifecycle, security, and all of the things. So outside Freshworks, I am part of a community. It's called GDG Chennai. I'm one of the organizers for it. It's a local developer community in Chennai, and we do meetups like these year round. So that's roughly about me. So before talking about Git hooks, I think let's talk a little bit about the common problems that we face in AppSec with regards to your shift left strategies. So when you talk about shift left, it ideally means that you're shifting all your security initiatives towards the left of the software lifecycle, right? Uh, so when you do that, there are a lot of problems, especially when it comes to the part where you are trying to implement solutions for secure coding, right? We try to bring a lot of secure coding solutions to the developer environment, and the idea is to just have a preventive solution in place to stop or arrest any issues that could creep in right at the coding stage, and also to just enable the developers to be more proactive rather than telling them about all the issues that come up after they raise a pull request. So these are all the ideas and the motives that we do it, but there are a lot of problems that we face here. One biggest thing is the adoption, and a lot of times we do not know how effective these solutions are, because end of the day, what you try to create is a feedback cycle wherein you want to see how effective your trainings are for these developers. So you want to see how effectively they use these platforms and tools and see how well they are able to write secure code. But you oftentimes don't know how far it is going well and all these things, right? Because developer environment is something that is sitting away from you. You don't know what's happening within the laptops, right? So when you try to implement certain solutions for your local scanning and all of that things, right, there are a lot of concerns that comes up from people. I think the emotion is quite similar with all of us, right? When IT or somebody tries to install agents and softwares on our laptops, we say that it tends to slow down our laptops, or it is blocking me from my flow, my workflow. It kind of affects my productivity and all of that. And I think the last point, which we quite commonly hear, shipping features are very important than fixing security issues. Uh, well, I mean, it's not that security issues aren't a big problem, but then, when you look at having features versus flaws, I think features are always something that stands out in a business, right? So these are all the concerns. And also, when implementing a solution, something that is going to be in a laptop for developers, it needs to be very native to them, which means that the tools that we choose and choose to run should be on a platform where developers are working on. It should be something that's fast and something that produces results which developers can easily understand. It shouldn't be something that only AppSec engineers can understand and work on, but the feed should be in a way that developers can understand, consume, and take action on those things. Very important part is that these findings should also be easy to ignore as well, right? Uh, let's say you open up a YouTube video and play. If you see an ad and you don't see a skip button, how frustrating it is, right? So just show the skip button there. If there is a finding, and if developers think it's relevant and something that it should be fixed, they will do it. If not, they might choose to just skip that part. And obviously, you have the later stages of your scanning throughout your CI/CD phase, and you can just uh, take action on those things. So yeah, so these are the top things that we need to look at. So let's probably start talking about this concept called git hooks. Uh, so in short, git hooks essentially means that you can run certain scripts when you have certain actions happening within Git, right? So before talking about hooks, I think we'll do a small introduction about Git for those of you who are not aware of it. Git is basically a version control system which allows you to have nonlinear development, meaning that you can have multiple streams of uh, file states or your project states where you are developing certain features in multiple branches, and you always have an option of diverging or converging those multiple features into one single stream. So that's basically nonlinear development. And version controlling is data oriented. There are a lot of version control systems, and Git is one of them. uh, Git basically uses data to control your versions. They don't really use your files to actually maintain the versions. So that's something which Git does. And also, Git can also extend to be a server, which we predominantly use through many vendors like GitLab, GitHub, Bitbucket, and many of those things. So if you're not familiar or you haven't used Git or you want to explore more about Git, there's a link below you can read about. That book has everything about Git VCS. For those of you know Git and use Git almost every day, you would know that on a standard basis, you would do these three commands. That is git add, git commit, and git push. So these three basic operations are something that almost everybody would do if they use Git, right? You add a file change, you commit the file change, you push the changes to a remote repository. So these are the three standard operations we all do. But what we don't see is that when these operations happen, there are certain events that happens in the background, right? So for every action, there are certain events that Git would trigger, and these events can be consumed in a better way. So let's say for an example, you have some sort of software and you click a button, and let's say that button triggers a webhook, right? A webhook, kind of an API call or an HTTP request. Now you can point that webhook to be sent to a particular endpoint, and from that endpoint you could probably consume the webhook data and do whatever you want, right? So that's how these events are. So basically, Git can broadcast certain events, and we can choose to uh, consume those events and do what we want with it. So just for these three actions, if you look at, there are five events that would trigger. And when you do git commit, you would have four different events happening. And for push, there is just one event. Now we're not going to talk about all these five events. We'll just talk about one as we go through. But ideally, what happens is that when there is an action A, you have an event A that is triggered. And for an event A, you can have a hook A, which will consume the data from that event. And you can do whatever you want with that data. So, Git hooks on a broader angle, it has two different types of hooks. One is the server-side hooks and the client-side hooks. So, server-side hooks are for Git servers. When you host Git in a server mode, you can have some server-side hooks, wherein you can choose to run certain scripts when you receive data from the client. And client-side hooks are the ones that we just saw now, right? So, these are some examples. So, generally, if you see where do these hooks sit? It is usually present inside the .git folder, inside the hooks folder of each repository, right? And hooks are usually, written in Bash, or they are either executables. It could be Linux executables, Mac binaries, or Windows path files. Uh, it could be any of these formats, and Bash is something that is very native, and Git can easily run Bash scripts. So that's about Git hooks. Uh, we will start talking about pre-commit hooks. Um, so the word pre-commit ideally essentially says, right, it is something that would run before a commit. So let's say for an example, you type git commit and you try to commit code that's basically trying to save the file state, right, your project state. What happens is that an event is executed, which is called pre-commit event. Now, the pre-commit event is basically the state of your project where it is not committed. So this is just an event telling that, hey, Git is about to save certain amount of files to this project, and it presents all the data. So it will tell you what are the files being changed, what are the data that is changed, and all of that, and you can do whatever you want with it. And pre-commit is one of the most famously used, most commonly used Git hook because of a lot of reasons which we'll go through, right? So how pre-commit works? Uh, Ideally, when you type git commit and hit enter, you add all your message and hit enter. The pre-commit event is triggered. And in turn, if you have a hook written in your repository, a script which is in your repository, that hook will be executed by Git automatically. So whatever you put in that particular file, a bash script, will get executed for pre-commit event. So what happens after the execution of the bash file? Now let's say the script exits with certain exit codes, right? You can choose to block a commit or allow a commit. So if the exit code is 0 as usual, which means the script executed without any errors, which means you can allow the commit. So git commit will happen normally. If not, if it's a non-zero exit code, it would just stop the commit, right? So which means the file state is not saved, and you can probably do any changes you want. So that's how it works. Now, if you'd like to just test how this works, you can probably go to the .git folder of your repository. Inside the hooks folder, you create a pre-commit file, right? Pre-commit. And inside that, you can add some bash scripts. You can add whatever you want, and probably add something like exit code 1 and just save it and try to commit some file. You will see that it will not get committed, right? It will just stop the commit. So which means a non-zero exit code will just stop your commit and your files aren't saved. The state is not saved. And if it's 0, it will save. So you can just test it out if you'd like to see how it works. Why why would somebody use pre-commit hooks, especially in the context of security? That's because just like I said before, during the pre-commit event, you know exactly what the changes are. You know what files are being changed. You know what lines of code is being changed. So you can use certain scanners which could just scan those particular code changes. And if there are any findings, you can show it to the developers and they can choose to fix it, right? So since now the code is not committed, developers get the opportunity to fix it. Now there are a lot of pre-commit hooks out there in the market, like there are a lot of open source. Many of those attributed to being linters, code quality checks, code coverage checks, and all of those things. Uh, but this is also one place where we could have security scans as well, code analysis. Now, when you have pre-commit, what are some of the requirements for us or in general? Um, One is that it should be fast because you know that when you hit git commit, regardless of how big it is, right, how big the commit is, it would happen almost instantaneously, right? It would not take more than 2 or 3 seconds. So, which means if you have a hook over there, it should be something that would probably run for 30 seconds or not more than a minute. Even a minute is bad. So, anything more than 30 seconds is also not good. But then, for the sake of security and for the sake of being proactive, some amount of time spent over there is should be fine. So one of the biggest requirements is that it should be fast and do not block if your scanner fails or if your script fails for some reason, right? Block only if there are findings. Do not block if there are any failures in the scanner or with your script. So ideally also is that the script or your scanner that you have should probably work offline, right? Or if there isn't a possibility it cannot work offline, just probably skip it. Don't run this hooks. Reason is that the idea is to make sure you do not block the flow of developers, right? You not do not block them for any failures. You block only if there are issues in the code. So identify all the possible cases where it could fail and just make sure you just skip the scans or gracefully quit it, right? Also, we know for a fact that security scanners tend to give a lot of false positives, and it is also possible that developers find it in their machines. So provide them a way to ignore false positives. Now, there are certain options that the scanners would provide, like adding comments to the files, comments to the code block saying that ignore this particular code block from being scanned. So that is something the tools would provide. And if your tool which you use provides such features, just expose it to the developers. If not, then just look for alternate ways of doing it. So this is another requirement. Finally, this is something which may or may not be needed is collecting metrics for your team. Now, this is it's very not common. So some teams would choose to get metrics, some teams wouldn't choose, and this is totally up to you, right? So these are the requirements. Now we know what to do and how to do. We have all the base. Now the problem is that it is hard to distribute, right? You are writing a bash script and you have to distribute across to all the developers. Let's say your company today has 100 people, you have to give it to 100 people. Tomorrow, if it's 500, then it's 500, then it's 1000, 2000, 3000. You have to have a way where you can do this in a scalable fashion. And copying scripts to all these computers is definitely not an option. Second thing is that we do not know if everybody's really using it or not, right? So these are the two big challenges that we have. Now, when looking around the internet, if there are any potential solutions, we just came across these two things. One is the pre-commit framework and the Husky framework. Now, don't confuse pre-commit hooks for the pre-commit framework. I know the names are similar, uh, but pre-commit framework is an open source project that lets you manage these pre-commit hooks. And Husky is also something similar, but then you can have any types of hooks configured using Husky. So pre-commit is very specific to pre-commit hooks, whereas Husky can be used for a lot of different things. All the 13 plus Git hooks which Git supports. So Pre-commit framework um, works a little differently. So if you're writing raw Git hooks, you would write it within the .git folder, and that's how it works. But when looking at pre-commit framework, it manages the hooks for you. So they present an abstract way of defining all the hooks by yourself. So the way that they do it is using YAML templates, and if you just look at the website, they would tell you how to define hooks and do all of that. If it's something that interests you, just look at the website and you would know. But there are also problems here that we found. Uh, there is a lot of dependencies. One is that I think it needs Python to be installed. Um, then it's also that you have to have developers to install the pre-commit framework, and they have to run certain commands to install the hooks in their laptops. And also the problem is that you have to do this step manually for each and every repository that you're working on, right? So this is something that's painful. Also, another problem is that this pre-commit framework would overwrite or disable any custom scripts which you might have in the hooks folder that you have written by yourself. So that's another really big problem. So also, since I said that you have to manually install it, it also means that you have to manually add a configuration YAML file to each and every repository and add it as part of your versioning. So, which means it should be part of your repository all the time. Only then people can use those templates and install the hooks. So, driving is a little hard with this because step one is adding these YAML templates to the repository. Second is that getting developers to do the installation part, right? So this is another problem. Now there are a lot of other limitations too, which I will talk about after talking about the Husky framework too. So Husky works a little differently. You create and store the hooks in one single location in a dot folder called Husky. It just stays in one single place in your computer within your top level user folder, home folder. And but then you still, I think, requires users to install them manually, or you probably have to configure Git to, use the Husky folder as the hooks template folder. The problem is that again you have to make people install Husky framework, which again you require Node to be present. You use npm to install Husky. And the second part is that installing the hook is a little difficult. It's not conventional. The problem is that since Husky uses the new Git hook specification, uh, this would basically supersede any other hooks which are present locally within your repositories .git folder. So which means any custom scripts that developers might have written will not run. So that is one particular problem. Also, let's say the team is using some pre-commit framework as well, right? Which means Husky wouldn't really play well with pre-commit frameworks or any other frameworks for that matter. So these are some problems. Uh, so combining all of them together, the problems we faced and why we didn't want to go with the existing solutions is that these frameworks enforce certain opinions which might not be compatible with any of the existing hooks or any workflows that the teams are already following, right? So, which means if you're using a framework, you might require all the teams and developers to convert or switch to this particular new frameworks that we are trying to drive. And as an AppSec team, I don't think this is really a good idea to do because already trying to push a lot of changes into their pipeline would keep them furious. And you go tell them that change this particular framework is something that you don't really want. So that's another problem. Also, just like we spoke before, it would rewrite all the existing hooks that is added by the teams by themselves or any other frameworks. So they don't really play well. So they're not intercompatible. So that's another big problem. Um, Another Another issue is also that migration of any existing hooks or adding new hooks is a little difficult. It's a little tricky and trivial. So these are the big problems that we faced. Uh, so another thing we thought about is that let's say today you add a particular hook to every single developer in your company, and tomorrow you want to update those hooks for some reason. Um, Using frameworks will cause a little bit of trouble because one, they are either a part of the repository, which means they are part of 100 plus repositories now. The problem is that there would be multiple branches, and these files would have already gone through different branches. And what we would basically do is just change the file in one particular branch. It would take a long time for that particular change to propagate through all the branches, right? Developers wouldn't check in the new changes, so they would not have the latest hook running on their machines. So that is another problem. Making developers run certain commands is something that we can't expect everybody to do for every repository that they clone or create, right? So we cannot rely on somebody to run certain things and expect it to just work magically. So that isn't gonna work. And just like we spoke, it isn't a global solution, and so the frameworks don't really work all the time. So what we thought was, why don't we write our own hooks installer, right? It is something that's quite challenging. I'll tell you the reasons why. But the requirements are the installer should ensure that all the repositories present in your the laptop should have the hooks installed. The installer should be able to modify or add new hooks on the fly. You just provide a new template. The installer should be able to make changes to the existing template and reflect that across all the repositories immediately. And that's something we need to do. But the problem is that this particular installer does not keep running all the time. So it cannot check for these hook states, and it cannot update these hooks on the go. So the question was, can we rely on Git instead to do this, right? So that's when we explored Git templates. So Git templates is an option where you can have templates for your repositories. Templates being for commit messages, templates for hooks, templates for your repositories, and a lot more. So Git allows you to create templates for all of these things, and you can use templates which can be propagated across all the repositories. And this is something that is very global to every laptop. So it can work like a breeze. So what we did was we went ahead and wrote a pre-commit template, right? So all templates in Git is present in one single default folder, which is present across different operating systems. These change, but it's usually present in the Git core folder. But we didn't really want to alter any of the defaults, so we just left those, and we went ahead and created something called .git templates, right, in the home directory. Uh, Now, .git templates is something that most of the market solutions also use. So we thought we can follow a standard convention of Git templates and not name it something else. So that tomorrow, let's say developers want to have a different their own hooks or something, they can simply use the Git templates folder, right? So within the Git templates folder, we create a pre-commit template, and we just created a bash script, a very simple bash script, and we just tried to see if it can run. We added a simple scanner, and we just checked that if the bash script was able to propagate the right exit codes. If there are findings, give us an exit code of one or non-zero, any non-zero exit code, and provide zero if there are no findings. Uh, so this file should also have executable permissions. Since we created it wouldn't have, so you have to provide the executable permissions to the pre-commit file. And as one last step, you would have to do the configuration. You have to configure Git to use this particular folder as the template directory. So you add that as well. So step one, creating a pre-commit template and adding it to Git is done. Step two was question, how do we deliver it across the organization? Uh, so certain companies might have IT softwares which would help us do this. So we could probably take help from IT. But if your organization does not have certain softwares like MDM and all of those things, uh, you could probably deliver it as uh, a bash script which can be curled from somewhere. So you can ask developers to run this curl bash command and have this script executed in your laptop and have the template set within your machines. That is one option. But otherwise, if your company has an IT team which already has some sort of MDM softwares which can run remote scripts, then we could probably take help from the IT team to do it. Now, there are a lot of things that we obviously messed up the first time. Uh, so we knew that we had to write templates, and you provided to Git, and we thought it would automatically work. But it wasn't the case for the repositories already present in the systems. Only for the newly created or cloned repositories, the hooks were present. So we had to reinitialize the repositories, right? Already present repositories had to be reinitialized. So you run git init across all the repositories, and we just started that feature. But then we did not think about the existing hooks which were added to the repository. So there were two cases. First thing is that when you run git init across your repositories, let's say one of the hooks was not empty, right? Let's say a developer had some custom script which was present in the pre-commit file or some other file. When you run git init, since the file isn't empty, Git will basically skip that file. It wouldn't update it. Okay. So we thought the hooks would run, but then for certain repositories, it wasn't happening. So the next step was we just chose to delete those files and reinitialize Git. And then we learned that we shouldn't do that because the custom scripts might be present, and we had to check the contents of the file before rewriting them, right? Uh, so you check if there are any other scripts other than our scripts within the file. If yes, then just modify that particular part of the hooks file and not the entire thing. So these are some of the lessons that we learned when we distributed this particular system. So how did the final version look like? You have a Git template. You have a way of delivering the Git templates to the developer laptops or machines. And you have to figure out what are the various Git repositories present in the system and reinitialize those repositories. When doing so, do not delete any of the existing hooks. So if there are custom scripts, just append your security scripts to the pre-commit file and move on. If not the case, if it's just your security pre-commit, just replace that with the new script. So these are a few things that we note. And finally, you also have to provide a convenient way of skipping the security scans. Uh, so the first way is the Git's way of doing it. That is, use the no verify flag within Git. So when you do Git commit, you add the flag no verify, and Git would essentially prevent any of the pre-commit hooks from running, right? So that is one option. But then we didn't want to do that, and I'll just talk about it why. Rather, we provided a environment variable which folks can set and commit. Why? There are certain significance because when you run git commit no verify, what happens is that Git would ideally ignore all the pre-commit hooks, right? So let's say the developers had their own linting tools and quality checks and all of that. All those things will not run, right? So just for the sake of stopping the security scans from running, you cannot stop all of it. So we provided a way of just preventing the security scans from running, and it was to use an environment variable at the runtime. You just add something like security pre-commit 0 and git commit. And our pre-commit hook would check for this variable at the very beginning itself. And if it is set to 0 or 0, then it would not run the hook, right? It would just exit with exit code 0. So that's what we did. So this allows developers to skip just a security scan before, committing their code. So this is one nice feature, nice way of doing it. Finally, there are certain things to be mindful about. Is that, like I said before, for any scanner or network errors, just exit gracefully. Do not throw any errors. Do not block people. Another thing is that when you create a template, have some starting and ending patterns, because let's say tomorrow we have to edit these templates. These patterns will help you identify where your script is, right? Because within the template file, your script could be at the starting, at the middle, at the end, can be anywhere. So if you add certain patterns like these, we can identify these scripts wherever it is tomorrow, and you can just modify the lines between these starting and ending patterns, right? Also, do not rely on Git init to update all the hooks. Just make sure we compare all the files and update them as necessary. There might be cases where you need certain configurations and certain secrets for your scans to run. Just make sure it is present in a folder somewhere locally within the laptops. You don't really want to do this in the runtime or pack it along with your scanner binary. What you can do is basically keep them in one particular folder where usually somebody would not access or modify it, right? So what we did is in the users home folder, we created a dot security folder, and we created a structure directory structure. For every tools, there would be a tool name, and inside that there would be a dot config file, right? Reason is that that dot files and folders are usually not picked up by any file viewers and file managers. So these are ideally good to use, right? Also choose the right scanner, because you know there are a lot of scanners which are heavy in nature and which are slow in nature. We do not want to use such scanners in the local machine. Choose what exactly you want to scan. Is it the code? Is it for secrets? Is it for the dependencies? Just make sure you have the appropriate scanners. Don't overload your recommit. It should be fast. It should be lightweight. Ensure that you have minimal dependencies. Make sure that you do not want to have more dependencies installed into the developers' machines because uh, it would lead to two different things. One is polluting the environment with dependencies. Second is that these dependencies could be used by developers for something else, so that they might upgrade it tomorrow or delete it tomorrow, do whatever, and your scripts might stop working. So don't do that. Also, another thing is that any findings which come out of these scanners are displayed in the terminal, regardless of what editor and all of that you use. So make sure these findings are displayed or presented beautifully, because you're showing it to developers. It is something that they should understand, right? So which means you might have to write a little bit of code to modify this and make it look good. And probably if you're using something like template engines, that is something that could help you make your findings look good for you, the developers, right? Let's say there are certain tools which only emit JSON outputs or XML outputs, right? Which means you cannot just show that to the developers, right? So we might have to present it in a good way, and template engines is something that could probably help. If you're using scanners which are Docker based to prevent dependency pollutions, make sure those images are always available. If you're using a public image, make sure you have a fork of it somewhere else, because public registries like Docker Hub have rate limits. So it's highly possible that sometimes the images aren't available. So don't do that. Uh, Make sure that image is always available whenever somebody is trying to pull the image. Make sure the image is also small in size, because for every scan, it is possible that your images are getting pulled. Reason I tell this that Since you always want to have the latest image running, you will have to have the pull always flag added to your Docker run. So when this happens, it would pull the image every time you do git commit. And let's say the image is like more than 50 MB or 100 MB. People using slow internets would not be able to work fast. The image pulling time itself would consume a lot of time, and that would lead to delays and developer frustrations. There are some caveats. So there are integrations within IDE and your desktop clients like GitHub Desktop and things like that. These integrations will not honor security pre-commit flags or any flag that you use to skip the scans. Reason is because they do not run in a environment that allows you to execute custom git commit. It would run by itself. So which means you do not have an option of providing this flag, but you could probably have it as a global environment variable, but then that's really bad practice to do. So this is something we haven't figured out what to do about. And there are a lot of open issues already on these integrations and desktop clients, but it doesn't seem like there is a solution out in there we can use. So which means when you use git hooks and let's say developers are using these desktop clients or IDE plugins, there is no way you can skip the git hooks unless you choose to delete those files or you use git commit no verify. So you cannot skip these scans when you use git hooks with these clients and IDEs. So which means even if there are errors, then which means the developers are stuck with those errors, and which is also one of the reasons why we should gracefully exit for any scanner errors. This is just optional. Speaking about metrics, so we chose to collect metrics like the username, host name, email ID from the git config, repository branch names, the time taken for the scan overall, and we would also have scanner specific details. Let's say you have more than one scanner, you need individual scanner information and the time taken by each scanner. Um, so why do we collect all of this? It is there are different things you can do with it. Uh, the biggest one is understanding the adoption rate and the performance and all of that. You can probably improve your performance and all of that. The other two things are more on your bigger AppSec perspective to understand your training effectiveness and personalized course content for people and all of those things. Other is that you can map your GitHub pull requests to the local scan to see how the issues have propagated in case you want to have a very exhaustive vulnerability management system and all of that. So these are just optional and very company specific. You can choose to do it or not. That is up to you. Uh, so that's mostly about it. Brings us to an end. Thanks so much. This could have been a lot of information, but hope this was really insightful for all of you. Thank you for having me, OWASP team. It was great being a part of this conference.
Thank you, Naveen. It was an amazing talk. It was for. Thank you for sharing wonderful insights with respect to Git hooks and pre-commit hooks. It was really good. I'm sure audience has a lot of questions and they will reach out to you on your socials. Also, thank you everyone for joining the session and a big thanks for Google on sponsoring this. See you all in the next session. Goodbye.
Bye.